Hi, my name is Shana McKay and I blog about math at scaffoldedmath.com. I was a teacher for 13 years here in Massachusetts, where I live with my husband and our 6-year-old daughter. My undergraduate degree is in environmental science. I love everything about nature, and my master's degree is in mathematics for teaching. Today my session is on ways to bring algebra tiles into your classroom. It's really geared towards teachers who haven't yet used them, but I'm hoping that even if you have used them in the past, that you can get some tips from my video. Please don't forget to download the algebra tiles resources. There's some printable algebra tiles that you'll see me use in the video, and also the different mats that you'll see in the video that help scaffold the algebra tiles. I hope you have a wonderful summer, and thank you so much for being here. It means a lot to me. So without further ado, let's get right into integers. Here I have 4 integer problems. This mat is in the downloads. You can use it either to give to students by putting in a page protector and using a dry erase marker, or you can use it if you're teaching online. You can have this under a document camera, or even in the classroom have it under a document camera. Down here there's a key. A 1 is just 1. A -1 is -1. And then if we have two next to each other, a negative 1 and a positive 1, that's going to equal 0. And that's going to come in a little bit later when we do subtraction. So let's put these back. And this first problem here, -2 plus 1. We take our -2 and we add in a 1. And then we can zero it out. -1 and positive 1 is 0. So our answer here, -2 plus 1, is -1. Let's look here, 2 plus -1 and a -1. The 1 and the -1 will zero out, and we'll end up with 1. -2 plus -1. Sometimes I like to say -2 and -1. And since we're not making any zero pairs there, the answer will just be -3. And this last one, 3 plus -5. We have a few pairs that we can zero. And we see that we have a -2 left. So 3 plus -5 is -2. I'm going to clear all this off and bring in some subtraction problems. Okay, our first is -2 minus -1. So let's get our -2. And we want to remove one -1. So we have one -1 left, so -2 minus -1 is just -1. Over here, -2 minus 1, we have our -2. And we need to subtract a positive 1, but we don't have any positive 1s to subtract. So that's where this key will come in, the positive 1 and the -1. So let's bring in a 0. This positive 1, -1 pair here is a 0. And we can add 0 to whatever we want to add 0 to, and it'll just keep that number the same. So here we still have -2, and we want to take away a 1. Now we have a 1 now. So we just take this away, and we're left with -3. 2 minus -1. We want to subtract a -1, but we don't have a -1. So we'll add a -1 in with its one pair to make a 0. And now we can take away a -1. And we're left with 3. And our last one, 1 minus 5. We have 1. We want to take 5 away from it, but we only have 1, so we'll need 4 additional 0 pairs. Okay, so now we have 5 that we can take away. We'll take away all the green ones, all the positive 1s, and we're left with -4. This is a tool that I developed as part of my graduate thesis for adding and subtracting integers. A problem like 3 plus -7, this is how you'd use it. You'd find 3, find negative 7, and ask which of the numbers is farther away from 0, and that would be negative 7. And then counting the spaces between the two numbers, 1, 2, 3, 4, which tells us then that 3 plus negative 7 would be negative 4. It works with absolute value. It does fold out like this to look like a traditional ruler. It folds in half so the students can compare the distance from 0 of the positive and negative numbers that they're adding. Here's another problem, negative 5 plus 12. We'd find negative 5, find 12. We see that the positive 12 is farther, so our answer will be positive. And then we just count the spaces.
1, 2, 3, 4, 5, 6, 7.
So we can see that negative 5 plus 12 equals 7. I'm going to use this graphic organizer to show you one way to use algebra tiles to multiply integers. Right here we have a negative 2 times a negative 5, and we have our t-chart here. And down here there's some keys to remember. I like integer multiplication to bring in the language of math. Some of these words here will translate into math symbols. The opposite of a negative is a positive. So I'm going to use that when doing this multiplication problem, negative 2 times negative 5. So first let me set up the problem. So here I have negative 2 times negative 5, and I can talk about this word of. The opposite of a negative is a positive. So I'm going to fill in all of these with positive 1. So here we can see that we have 10 positive 1s, so negative 2 times negative 5 is positive 10. If I were to switch these and change my problem to 2 times negative 5, I'll then have the opposite of a positive. We know that the opposite of a positive is a negative, so I will switch all 10 of these ones to negative 1. So here we can see that 2 times negative 5 is negative 10. Now there are other ways that you can use algebra tiles to multiply integers. This is more of a graphic organizer way. You can use this while teaching under a document camera or from home, or you can give this to students to practice at their desks with their tiles and put this in a page protector. With integer division, we'll think about it in reverse of integer multiplication. We'll start with an area and try to find the missing side length. So let me set up the chart here with 8 tiles. Now I set it up like this because I know that the side here will be negative 2, so that I want 2 rows. We can still use the same keys to remember as we did for our integer multiplication. We're just missing this side. If we had started with a negative 2 and we ended with a positive 8, what must our missing length be? It would have to be a negative 4. And let's see if this is true. The opposite of a negative is a positive. So we know that 8 divided by negative 2 would be this length here, negative 4. Let me clear all this out and we can make another problem. Here we have negative 10 divided by negative 5. Negative 10 is kind of a weird area to have, but it's kind of nice to use algebra tiles because it makes it a little bit more concrete to think about. So I'll set up 10 negative 1 tiles in the area section. Now I know that one of my side lengths is negative 5. I could put it here and just move the tiles into 2 columns, or I could put it up here. In order to end with a negative 10, I know that the opposite of a positive is a negative. So I know that my missing side length would have to be positive in order for my area to be that negative 10. And let's check it out with our key. The opposite of a positive is a negative. So negative 10 divided by negative 5 is positive 2. Here I have 100 blue tiles for a prime versus composite numbers investigation. I also have my little daughter here. She's only 6, but she's being a good sport today to help demonstrate this activity. First, I'm going to give her 12 tiles and see if she can arrange these into a rectangle.
I think I can.
Awesome. So 12 can be arranged into a rectangle. So our number is composite. So here's 17 tiles. Can you arrange those into a rectangle?
Maybe if I take, maybe it's a 2. How about a 5 row? Or how about this? It's all here. I'm not really using the order, so I'm not using the order. I'm not using the order, but it actually is a rectangle. It's a rectangle. Right here, and if you just put all of these into place, you can see this is a rectangle.
The number is prime or composite?
It is prime, even though you can make a rectangle out
Aha, very good. High five. Let me give you 4 more. So now you have 21. Can you make 21 into a rectangle?
Let me see. I wonder. Maybe. Or you might get it. It's a little bit. I don't know. Okay, it's not it doesn't look like it might be a number. Oh, maybe it is a number.
Okay, so this number.
So, like, it's like here.
Those are yours.
Okay, remember. Or this doesn't need to, so it's B. I saw the 2 rectangles together. Right.
Okay, start free.
And let me see.
Aha. Does that work?
It does.
Let's pull them over. Cool. Okay, so we can make a rectangle out of 21 tiles. So is the number prime or composite?
Composite.
Aha. Very good. Before we get started using algebra tiles to solve equations, I want to let you know that this solving mat is in the downloads, and so is this keeping the balance reference for students, just to remind them that if we take something away on the left, we have to take that away on the right. Another reference that's in the download is a zero pairs reference, where we can zero out whatever we have with the opposite sign. So we'll see that as we start solving. One more thing is that if I was in the classroom, I would put this mat in the page protector and use a dry erase marker. But for the camera, it'd be too much shine, so instead I'm just going to put the equations on little pieces of paper. So our first equation, 2x plus 5 equals 9. Let me set that up with algebra tiles. Now here we can remember to keep the balance. I have 5 1s on this side and 9 1s on this side. If I sweep away these 5, I can sweep away 5 on this side. Now I have 2x equals 4, and all I need to do now is think of proportions. If 2x equals 4, then 1x equals 2. Our next equation is 4x minus 4 equals 4. So let me set that up. So here we have 4x minus 4 equals 4, and we want to remember our zero pairs, because we don't have the same thing on both sides here. We have to zero out these 4 negative 1s by adding 4 positive 1s on this side. But because we add 4 positive 1s on this side, we'll have to add them on this side as well. So here we have 4 negative 1s, and now we have our 4 positive 1s, so those will swipe away because of zero pairs. And now we have 4 x equals 8. We can think about proportions again and see that x equals 2. Our next equation has variables on both sides. So let me set these up. Now right away I see that we have x's on both sides. I have 3 here that I could swipe away with 3 from here. Now we have -5 equals 2x plus 1. Our 1's here are negative and our 1 here is positive. So let's use 0 pairs and get rid of this one. When I add a -1 to this side, I need to add 1 to this side. These will swipe away, and I'm left with 2x equals 6, -6, excuse me. I'm going to arrange my -1's like this so that I can use proportions. And I can see that x equals -3. Our next equation is another one with variables on both sides. I have -2x plus 1 equals x plus 10. Right away I see I have a 1 here and I can take one of these away, keep the balance. And now I have -2x equals x plus 9. Now I want to look at this side because this side still has x. It has an x and it also has numbers. So let me get rid of this x by zeroing it out and then adding a -x to this side to keep things balanced. These swipe away. And I'm left with -3x equals 9. I can use proportions to see that -x equals 3. Now I don't really want -x because I know that -x is -1 times x. I want positive x, so I'm going to flip it. Now if I flip this side, I need to flip these. And I can see that x equals -3. Our next equation has a 1/2 x. What I like about using paper tiles is that you can cut them. So here I cut an x tile into half, and I did it on the diagonal to kind of bring another part of math into our solving. How half of a rectangle is a triangle. It's just fun to kind of bring something in. You can certainly cut it straight up and down if you'd like. So I'm just going to leave 1/2 here. And 3, and 5 on the other side. Now right away I see I can swipe away 3 here, and 3 here. And I'm left with 1/2 of x equals 2. I don't want half of x, I want a whole x. So if I double the amount on this side, I need to double the amount on this side. So now I can see that x equals 4. Our next equation looks super simple. 2x plus 5 equals 6. And right away I see that I can swipe away 5 on the left and 5 on the right. And I'm left with 2x equals 1. I like using the paper tiles because I can cut them. So I'm actually going to cut this one in half. And I can see now that 2x equals 1. So 1x equals half of 1. Or x equals 1/2. One more thing, if you're solving x squared equations in class, you can set it up where you have all your numbers on one side and your x squared on the other side, and the goal would just be to arrange your numbers here into a square. So here we have 16. Can we arrange these into a square? We know that x squared is x times x. So in our grid here, we have 4 times 4 to get 16. So x equals 4. But hold on a second. 16 negative 1s arranged into the square is also x squared. We see that it's negative 4 times negative 4, which is positive 16. Algebra tiles are great for simplifying polynomials and for combining like terms. If we give something like this to students, sometimes they get a little overwhelmed, they're not sure which are like terms and how to go about simplifying. But with algebra tiles, the process gets a lot more intuitive and makes it much more concrete for those students who need it, and actually all students. So let's take this away. I want to just show you here, here's a key. We have an x squared is the large square. We have the x, and then the tiny square is just the 1, the constant. Let's put those over here, and let's bring in our first polynomial to simplify. I'm going to build this polynomial with algebra tiles. So here we have all of our algebra tiles to go along with our polynomial. You can see that there's so many of them that they hardly even fit on the mat. So what I'm going to remember here is that same size tiles of different colors will zero out. The zero pairs reference is in the downloads that you can grab. So I'm just going to start stacking. An x squared can go with a negative x squared into the recycling bin, and so forth. And these are the pieces that I have left over. I have a negative x squared, I have a negative x, and a 1. If we were to simplify this on paper, we would find that the simplified answer is negative x squared minus x plus 1. Another great thing about using algebra tiles to simplify polynomials is that it makes it really intuitive ordering these in descending order. So we can see that the x squared term is kind of the largest, then we have our x term is kind of, the middle size, and the 1 is the smallest. So it makes it really kind of obvious to the students that the way that they should order them to put them in descending order. Our next polynomial to simplify is 2x minus 1 plus 2 times x minus 1. Now with algebra tiles, we're going to think about this part here as two groups of x minus 1. So let me build this with the tiles. There's my 2x minus 1, and then I'm going to build two groups of x minus 1. And I want to add these together. So I just made a little addition sign. If you were to have this mat in a page protector at school, the kids could use a dry erase marker on it to write the plus sign. Now I'm just going to add these together. So I have 4 x's and 3 negative 1s. So my simplified answer is 4x minus 3. Now let's look at a polynomial where we're subtracting some groups. This here is 3x minus 2 times, in parentheses, 2x plus 1. Let me build that. So here we have our 3x minus 2 groups of 2x plus 1. So at first we could just start subtracting. X minus x, x minus x, x minus x. Now we still have a 1, and an x, and this negative sign. this negative sign is going to tell us that we need to take the opposite of what's here. So our polynomial here will simplify to negative x minus 2. There's other ways that you can do this one. Let me back that up. Here we have our 3x minus 2 groups of 2x plus 1 again. And if we don't want to be subtracting, if we feel more comfortable with adding, we can swap that sign, which will then require us to swap all the signs of our terms to the right of the sign. Because we're taking the inverse operation, so we'll need to inverse all of our terms. Now what we can do is just zero them out. X and negative x, x and negative x. And we end up with negative x minus 2. Algebra tiles are great for bringing deeper understanding into multiplying polynomials. Here we'll use x squared, x, and 1 when we're multiplying. The key down here is just remind students which to use. And this is also in the downloads, this polynomial multiplying mat. So I'll set up one problem. Clear this off. We have x plus 2 times x plus 3, and I'll set that up on this t-chart. And then all we'll have to do is to fill in the area with the correct size tiles. So x times x would give us an x squared. 1 times x. This x-shaped tile fits perfectly in this space. I'll just fill in the rest of them down here. And then in this space here, we're going to be multiplying these ones by these ones. So each of these would be a positive 1 for the positive times positive. Okay, so the last thing we have to do is just count up all the tiles that we have. 1x squared, 1, 2, 3, 4, 5 x terms, and then we have 6 of these little 1 tiles. X plus 2 times x plus 3 would be x squared plus 5x plus 6. Here we have x minus 1 times x plus 4. I'll set that up on the t-chart. And then we'll just fill in the area with the correct size tiles. X times x is x squared. Down here will be 1 times x. And then over here we have positive x times negative 1, which will give us a negative x. And then in this space we'll have negative 1s because we have a negative 1 up here and positive 1s on the side. This time when we count up all our tiles, we have 1, 2, 3, 4 positive x's and 1 negative x, so one of these will cancel with this one. So we'll end up with x squared plus 3x minus 4 This time when we fill in, we'll end up needing 2 x squared tiles. Here we have negative 1 times x, which would be negative x. And same here. Over here we have positive x times negative 1, which will give us that negative x. And in this space right here we have negative 1 times these negative 1s, which would be negative times a negative or positive 1s. So when we put it all together, we end up with 2x squared minus 5x and then plus 2. We can use algebra tiles to multiply when the x term is negative. And this time our x squared term was going to be negative x squared because we have a negative x times a positive x. We'll just flip our tile over and use the negative x squared side. Negative x times these ones will be negative x. And then positive x times these negative ones will also be negative x. And lastly, all these little spaces here will be negative times positive, which will be negative. When we count all of our tiles up, we have negative x squared, 1, 2, 3, 4, 5, 6, 7 negative x's, and 12 negative ones is negative x squared minus 7x minus 12. This factoring mat is in the downloads, and I just want to show you this key. This right here, we have a 1x and a negative 1x will equal 0. That'll come in when we have negatives in our trinomials that we'll be factoring. We can start with x squared plus 5x plus 6. I'm going to take in one x squared tile, 5x tiles, and 6 little tiles. Now the goal here is to arrange the tiles into a rectangle. Even though this configuration is a rectangle, it doesn't work because we still have 2 tiles we have to fit. So let me try again. There we go. Now all of our tiles have fit into a rectangle, and we can see that our trinomial here will factor to x plus 2 times x plus 3. Let's pull in 1x squared tile, 3x tiles, and negative 4. And I'll try to arrange these into a rectangle. We have these 2 negative 1 tiles over here, and something else, we have negatives here, but x times x should be giving us a positive. So we are going to need to use this 0 pairs idea here where we have one x tile and one negative x tile to equal 0. And now we can arrange these in here and see if we can then fit in these extra 2. And here we have all of our tiles arranged, everything fits, and it makes sense that we have our negatives aligned here. What is important to remember is that you can't have a red and a green tile right next to each other. So if you do bring in 0 pairs of tiles, the same signs will be next to each other. So we can see here that x squared plus 3x minus 4 will factor to x minus 1 times x plus 4. So there is some trial and error involved, and that's okay because the students can be given the tiles, given this mat, and they can just practice arranging the tiles and experimenting to see if they can figure out how to make these rectangle areas given the tiles that they have. Our next trinomial is 2x squared minus 5x plus 2. And I'll try to make a rectangle. You can see that this won't work because we have one empty space. So let me try to rearrange the tiles, see if I can make that rectangle area. There we go. So I was able to use all the tiles to make a rectangle, and we can see then that 2x squared minus 5x plus 2 will factor to 2x minus 1 times x minus 2. Here we have a similar trinomial to the one we just factored, 2x squared plus 5x minus 3. And I'll try to make a rectangle out of all of these. So it looks like I got it, except if we looked a little closer, we can see that this would have a 1 next to it, and up here would also be 1 to have these as positive x. And we know that 1 times 1 is positive 1, not negative 1. So we will have to bring in some 0 pairs so that we can fit these 3 negative ones in where they belong. This is where the trial and error comes in. So I'll start with 1 0 pair, and I'll try to arrange these x tiles to fit in this negative x. If there is only 1, it does go by itself, since we can't have a mix of tiles like this. Now we have our area all filled in with tiles, and it does make sense now that we have negative 1 here, because we would have a negative 1 up top with 2 x's, and we would have an x and 3 positive 1s here, and we can just double check. X times x is x squared, x times x is x squared. 1, these 1 times x would be x, 1 times x would be x, and over here negative 1 times x would be negative x, and negative 1 times these ones here would each be negative 1. So we can see that 2x squared plus 5x minus 3 will factor to 2x minus 1 and x plus 3. Now I want to show you how I made the algebra tiles that were in this video. They're just made out of paper. It's actually a little heavier than paper. It's kind of a cardstock. And I printed out the algebra tiles that are in the downloads, and I cut them out into the squares here. And then I'm just going to apply some glue stick to one side really well, and then attach the 2 pieces together. I'm going to use this Elmer's Extreme Stick so that it sticks extra well. You can probably use white glue mixed with a little bit of water and a paintbrush, or you could use rubber cement, anything that would stick really well so that the tiles won't peel after laminating. You do want to make sure to add a little extra glue in this section because these are so small, they're more likely to peel. Now I'll line up the 2 pieces of paper, and then I'll put them under a few books to let them dry. You do want to let them dry extra so that when you laminate them, the glue doesn't peel. Now that the tiles are dry, I'm going to take a piece of lamination and put them inside and run them through the laminator. And lastly, I'll just cut the tiles on the lines. Now we have a durable set of algebra tiles that we can use for years to come. Thank you so much for being here today. It means so much to me that you chose to watch my video, and I'm hoping that you can take some of the things in the video about algebra tiles back to your own classroom. If there's anything that I didn't cover that you'd like me to cover, please just leave a comment. You can find my blog at scaffoldedmath.com. I'm also on Facebook and Instagram. I hope you have a wonderful summer. You sure deserved it after this year.